Now we're going to take a look at parallel and perpendicular lines. Parallel lines are lines that never intersect. In the graph below, right here, we have an example of 3 parallel lines. So the green, red, and blue are all parallel because they never intersect. Another feature of parallel lines is that they'll have the same slope. So notice our slopes are all 2, but they'll have different y-intercepts. So our intercepts vary. If they had the same y-intercept, they would not be parallel lines. Well, I guess technically they will be parallel, but they will be coincident lines. Our other type of line that we're going to deal with is a perpendicular line. These are lines that intersect at a 90-degree angle at a certain point. And for these lines, our slopes are negative reciprocals of each other. And the reciprocal of x is equal to 1 over x. So if they're negative reciprocals, it's going to be the negative reciprocal of x would be negative 1 over x. So in this example, our slope of the red line is 3. The negative reciprocal of that will be negative 1 over 3. And so looking at the slopes, making sure it's both negative and the reciprocal, that's one way to determine whether or not the two lines are perpendicular. So now let's look at a couple of examples. We're going to write the equation of a parallel line, or of the line parallel to 5x plus 3y equals 1, and passing through the point 3, 5. In order to do this, I would recommend first getting it into slope-intercept form so it's very clear what slope we are dealing with. If you can figure out the slope or you have a way of doing it directly from here, you can go ahead and do that as well. But I think the easiest way for most will be to first solve this equation for y, or get y on one side by itself. So I'm going to start by just writing down the equation. So 5x plus 3y equals 1. I know I want y by itself, so I'm going to get rid of this 5x by subtracting 5x. So I'm going to move it to the other side. That cancels out, and I have 3y equals 1 minus 5x. If you really want to, you can put the x in front, but I'm going to leave it alone for now. And our last step is to divide both sides by 3 to get y by itself. So when I do that, I get y equals, and I'll move x to the front now, negative 5/3 x plus 1/3. So this is my slope, my line. So now I can clearly see that my slope is negative 5/3 x. Now I know I want my slope to be parallel. So I remember parallel means that my slopes are equal. So slope 1 equals slope 2. So that's clear. So I know in my new line, my slope is going to be equal to negative 5/3, the one that I just found. But I know it also must pass through this line. So if I'm going to write it in a y equals mx plus b format, and we know that m is equal to negative 5/3, we can substitute the slope that we know into this equation, and we can also substitute our point in, like our coordinates of our point, and for our x and our y, and we can solve for b. So we did something similar to this before. You could also write it in point slope form. They didn't say which format to use, so if you want to do it that way, you can do that as well. So right now I'm going to substitute all that I know. So my y, and I'm just going to label, right, this is my x and this is my y. My y is 5, is equal to negative 5/3. My x is 3 plus b, and I'm going to simplify. So negative 5/3 times 3, well, the 3's cancel out nicely. And I'm left with 5 equals negative 5 plus b. To get b alone, I add 5 to both sides. Let me make a little room right here. So if I add 5 to both sides, this cancels out, and I'm left with 10 equals b. So now I know my slope, I know my y-intercept. I can substitute them both back into this equation to get my line. So y equals negative 5/3 x plus 10. And this is my final answer. So notice that I use the idea of parallel lines having the same slope to get my slope. And then I use the technique I used before. I substituted my point into my y equals mx plus b and my slope into the equation. I solved for b, I got my final line. So let's take a look at another example. So find the equation of the line negative 5x minus 3y plus 4 equals 0 and passes through the point negative 4, 1. So now I have perpendicular. Perpendicular, and I'm going to use this sign for perpendicular, means that m, I'm going to put 2 equals negative 1/3. I'm sorry, negative 1 over m1, right? So negative reciprocal. So first I need to figure out my slope, and when I figure out my slope, my new slope is going to be a negative reciprocal. And then I can use the same steps as before, substitute my point, define my line. So first, let's get this equation into slope-intercept form. So I'm going to just rewrite it over here. So 5x minus 3y plus 4 equals 0. I know I want my y by itself, so I know I need to get rid of the 4, move that over. So I'm going to do the opposite. I know I also want to get rid of the 5x. And just to save space, I'm going to do them both in one step. So whatever I do to this side, I'm also going to have to do to this side. So minus 5x minus 4. So here, these are going to cancel out, and I have negative 3y equals negative 5x minus 4. My last step to get y by itself is to divide both sides by negative 3. And here I'll have y equals negative 5 divided by negative 3. That gives me a positive. So 5/3 x. And same thing, plus 4/3. I have two negatives. So now that I have my equation in slope-intercept form, I can clearly see that my slope, my m1 is equal to 5/3. So m2, the slope of my new line, is going to be the negative reciprocal. So I'm going to flip this over and make it negative. So it's going to be negative 3/5. So that's my negative reciprocal. So now that I know my slope, I can now substitute, and I know that y equals mx plus b. That's the format I'm using. I can now substitute my slope and one of my point, not just one, this is the only one I know, and this is my x and y, into this equation and solve for b. So here my y is 1, so 1 is equal to negative 3/5 times negative 4 plus b. Doesn't work out so nicely this time, but it was a nice run. So here I'm gonna get 1 equals, I'm gonna just multiply my numerators, equals 12 over 5 plus b. And I'm going to subtract 12/5 from both sides. I know, but in order to do that, I need to make sure 1 is written in terms of 5/5. So I'm going to multiply the top just by 5 over 5, right? We know that's 1 over 1 to get that into fifths. So I'll get 5/5 equals 12/5 plus b. So now I have everything in fifths. I can now do my subtraction. So minus 12/5 minus 12/5. Sorry, my 12 doesn't look like a 12. Make a little more space. So here, 5 minus 12, that will give me negative 7/5 is equal to b. So now I have my y-intercept. I know my slope. I can substitute them both into this equation to get my final equation. So y is equal to negative 3/5 x minus 7/5. And that's my final equation.